Now suppose two friends A and B are talking to each other, right? So let's say A is saying something and B is listening to A, and for some time, and then B is saying something and A is listening to B, and we're just assuming that both are not talking simultaneously at the same time. So if A is speaking, B is just listening to what A is saying, right? And so how does this work? How do the two, any two people for that matter, talk to each other? So if you look at this biologically, this is how it works. There's, let's say this is A's brain, and okay, I need a bigger guy, right? Okay, this is A's brain, and there goes his mouth. So there's a nerve impulse that goes from the brain to the mouth, and then the vocal cords or whatever convert the nerve impulse into a sinusoidal audio signal, right? And this audio signal travels through air and enters B's ear, right? This is B's ear. And then again, the ear converts it into a nerve impulse which goes into B's brain. So essentially, the audio signal is basically transferring from A's brain to B's brain. Okay, this is definitely not a perfect sinusoidal wave. This is a sum of many sinusoidal waves. This is an audio disturbance, something like this, right? And so, um, and the media through which the signal transfers is just air in this case, and we're assuming that the distance is close enough that they can perfectly clearly hear whatever B can perfectly hear whatever A is saying. So this right here is an example of a communication system. All right, this is a communication system. The brain first sends the message, and the mouth is like a transducer that converts the message from a nerve impulse, or you can say, loosely speaking, electric signal to an audio signal, right? So we can call this the input transducer, and B's ears are the output transducers that convert the audio signal back to a nerve impulse so that the brain can interpret whatever A is saying, right? All right, so let's do something here. What if we, there goes A, there goes B. What if we directly transfer the nerve impulse from A's brain to B's brain? All right. If there's no, definitely, because the nerve impulse is going to the mouth and then it's transferring through air, then it's again converting into a nerve impulse. So why not directly transfer the nerve impulse so that B can just interpret whatever A is saying without having to, without having to actually hear what A is saying, without having to transfer the audio signal from A to B. So this is actually very loosely the basics of what of the studies going on in the world about, on people who can't hear, on people who are mentally sick, mentally ill, and disabled people, to help them to be able to speak, to be able to talk to other people. So it's not exactly this, but this is just an intuitive insight towards, to what they're trying to do, right? Now, so back to the communication system. Now, let's say that this distance d goes on increasing. Let's say B is going home from work and A is also going home from work, but they're going to take different roads. So they're moving away from each other, right? And still they just want to talk to each other, like while they're moving away sometimes you just keep talking and moving, right? So that's what's going on here. They're still talking, but the distance is increasing. So let's say the new distance is some d dash, right? Now again, A is saying something and B is trying to listen to what A is saying, but there's a car on the road. And this car seems to be much louder and much closer to B than A, right? So this information, and there's this information. So of course, as a transducer, the ear does not have a brain, so it's gonna transduce everything that it hears, right? It's gonna transduce this, convert this, as well as convert this. Now, as this signal travels from A to B, there are two things. One, the distance has increased, so definitely the amplitude of the signal decreases, right? So, and another thing is that there's another signal. Let's call this A, and let's call this the car signal C, right? So there's another signal that acts as a noise to this particular communication system, right? So this signal is like noise to the system A and B. However, consider this. There's this road, and there are more roads going on here, and A is going there, B is going there, another there, and there's this car, the same car C, and there's a person crossing the road right here. So again, they are trying to establish a communication system A B. And now this person crossing the road comes in the way of the car C. So the car blows the horn to make sure that the person gets out of the way. So how does this work? There's Alright, we won't get into the car stuff, but the signal comes out, the horn comes out the car, and the guy hears it, and the brain interprets it, and he's like, okay, he runs and crosses the road without being hit by the car. So this is also a communication system. Let's call this guy D. And now this is a communication system CD, right? Now, as we saw earlier, this signal C was like noise for A and B. But for this system C and D, the signal from the car is actually the information that has to be transmitted to D. So this signal is noise for this system, but it is not a noise signal for the system C and D, right? So noise is actually pretty much a relative concept. It's pretty relative. If it's noise for for a system A and B, it's not necessary that it's also a noise for a signal C and D, right? Right. So when you start studying communication, you think of noise as just it's something that we don't want, right? If it's something what you don't want, which you don't want from the point of view of a particular communication system, right? So now let's suppose that the distance has increased further, and now B can't hear a single word that A is saying. Alright? And why is that? Because of, again, the amplitude of the signal sent by A, it's just going on decreasing, and it's negligible. When it comes to B, there might be a lot of cars on the road where B is going, so there's also additional noise, so B can hear only a small amount of this signal, but larger amount of other signals that that are imposed on this signal, that are added to this signal, right? Noise is basically additive. So if this is a noise signal, it's gonna add to your message signal to produce a sum of the noise and the amplitude signal. So one thing is that the amplitude is decreasing, and another thing is noise is entering the system. So let's use the primitive ways. So what they did this, right? They attached, these are like cups of what any metal or something, and there's this wire, and it was actually a thread, and it started between the two, and this is A and this is B. So you speak in into this, and you put your ear in this, so you can get a better reception of the signal that is transmitted by A, right? So this was one way of doing it, but still there was this signal, there was still noise which we could hear, and the signal deteriorated. So we'll keep the base, we'll keep the wire, and we'll keep these. Let's call this the input transducer. Again, we're out of the biological system, so don't confuse this. This is the input transducer, and this is the output transducer. Alright? And why is this a transducer? Because A gives the audio signal, and this thing converts it into a signal that can go through this thread or wire. Okay, if you can assume this is a wire, then this audio signal gets converted into an electric signal, and again on the other end the electric signal gets converted back to an audio signal. Alright, we're not talking about the biological system that exists from here to here, and alright, we're not talking about this. We're talking about the system in between, the new system that we've established by establishing a wire, right? So it's just a plain wire, and this is A, and this is B. Again, if we have a large distance, we had D dash dash, the signal is going to deteriorate through the wire also, right? Even though we now have medium and it is a directed, flow of the signal, but still, it's going to go out to the surroundings. Sorry for the cough. Now, what we can do here is, okay, we'll just leave this system right here. We'll come back to this system later, and we'll call this AB double dash.